Matter is everything around us that has mass and takes up space, and it exists mainly in three states called solid, liquid, and gas. These states are not just different in how they look, but in how their particles behave. The particle theory is used to explain all of this in a simple way, by imagining that everything is made of tiny particles that are always moving, even if we cannot see them. In a solid, the particles are tightly packed together in a fixed structure. They vibrate in place, but do not move around. This is why solids keep a fixed shape and a fixed volume. In a liquid, the particles are still close together, but they are not fixed in position. They can move past each other, which is why liquids flow and take the shape of their container but still keep the same volume. In a gas, the particles are far apart and move freely in all directions. This is why gases have no fixed shape or volume and spread out to fill any space available. When we draw particles, we use a model to help us understand, but it is important to remember that this model has limitations. Real particles are not tiny balls drawn in neat rows. Also, atoms of a material do not actually have the same properties as the bulk material. For example, a single iron atom does not have the hardness or strength of solid iron. These properties only appear when many atoms are together in a structure. In chemical equations, we use state symbols to show the physical state of a substance. The symbol S means solid, L means liquid, G means gas, and AQ means aqueous, which means dissolved in water. These symbols are important because they tell us more about how substances are behaving in a reaction. Changes of state happen when substances gain or lose energy. Melting is when a solid becomes a liquid, and freezing is when a liquid becomes a solid. Boiling is when a liquid becomes a gas, and condensing is when a gas becomes a liquid. These changes can all be explained using particle theory. When a substance is heated, its particles gain energy and move more. If enough energy is given, particles can break free from their fixed positions or from each other completely. The amount of energy needed to change state depends on the strength of the forces between particles. These forces depend on the type of bonding and the structure of the substance. Stronger forces mean more energy is needed to melt or boil the substance. We can also predict the state of a substance at a certain temperature by looking at its melting and boiling points. If the temperature is below the melting point, it is a solid. If it is between melting and boiling points, it is a liquid. If it is above the boiling point, it is a gas. Nanoparticles are extremely small particles with sizes between 1 and 100 nanometers. They are so small that they may contain only a few hundred atoms. Larger particles, called fine particles, are between 100 and 2,500 nanometers, and coarse particles are between 2,500 and 10,000 nanometers and are often found as dust. One important idea in nanoscience is that if the size of a cube is reduced by a factor of 10, its surface area to volume ratio increases by a factor of 10. This matters because nanoparticles have a very high surface area compared to their volume. This gives them special properties that are different from the same material in bulk form. Because of this, a small amount of nanoparticles can sometimes do the same job as a much larger amount of normal material. Nanoparticles are used in many areas, such as catalysts, medicine delivery, electronics, cosmetics, and sun creams. However, there are also concerns because their small size means they may behave differently in the body or environment, and their long-term effects are not always fully understood. Now we go through the exam-style questions in a clear and correct way. Question 1.1. Which states are represented in boxes A and B of Figure 1? Box A represents a solid and box B represents a gas. Question 1.2. Give one factor that determines the strength of the forces between particles in a substance. The type of bonding between particles determines the strength of the forces. Question 1.3. Name the change of state represented by arrow C in Figure 1 and describe what happens during it.
The change of state is melting if it goes from solid to liquid.
During melting, particles gain energy, vibrate more strongly, and break free from their fixed positions so they can move around each other. Question 1.4. Rewrite the equation with state symbols to show change of state C. Bridge 2, S2 to bridge 2, L. Question 2.1. What state will gold be in at 2000 degrees Celsius? Gold will be in a liquid state because 2000 degrees is above its melting point but below its boiling point. Question 2.2. Why are fewer gold nanoparticles needed than bulk gold for the same catalytic effect? Nanoparticles have a much larger surface area compared to their volume, so more particles are exposed and available to react, making them more efficient as catalysts. Question 2.3. Approximately how many atoms are in a 3 nanometer gold nanoparticle? The correct answer is 500. Question 2.4. Why are some people concerned about gold nanoparticles in anti-wrinkle creams? There is concern because nanoparticles are so small that they may enter the body or environment easily, and their long-term effects are not fully known. That is the full, simplified but complete understanding of this topic, written in a way that builds real understanding instead of memorization.